Section 3.3, we have the directions to graph this function in using transformations. So the transformations here is the +3 and the +2. So the function, the parent function, is y equals 1 over x, and then that +3, the +3 that's inside the function, it's with the x. So that's going to be a horizontal shift in the opposite direction of the sign. So that's a shift left 3 units. And then the +2 tacked on to the end, that is our shift, our vertical shift. So that's shift up 2 units. So our f of x is 1 over x, and then we're doing our transformed function is going to be f of x plus 3 plus 2. So again, that horizontal shift is inside the function, and the vertical shift is outside the function. And that thing is what is equal to 1 over x plus 3 plus 2. So starting with the parent function. So if I don't remember what that graph looks like, I can always use an XY table to kind of refresh my memory. Plot a couple points. So if I try to plot in 0, I see it's undefined. So I know there's a vertical asymptote there. So I'll draw a vertical asymptote at x equals 0. When the denominator is 0, that means there's a vertical asymptote right there. And let's see, what else do we have? We can plug in a 1 and get 1 over 1, so that's in y equals 1. We can plug in a 2 and y equals 1 half. We can plug in a -1 and get a -1, and a -2 and get -1 half. So I can see the pattern here. I can see, let's see, if I put in like 100, you know what, I'll put in 5 because my graph only goes to 1, 2, 3, 4, 5. So I'll just put in a 5. At 5, I get 1/5. If I were to go bigger, go say to 100, then I'm going to get 1/100th. So I see that the bigger my x gets, the smaller my y gets, but I'm never going to go negative because of the way fractions work. I'm making that denominator bigger and bigger and bigger, means that my y is going to get bigger, smaller and smaller and smaller. So I'm approaching that y-axis. So there's another asymptote right here. And then I have some points I can plot. Let's see, there's 1, 1, so there's a point here, and that is over here as well. And then I have 2, 1/2, 3, 1/3, 4, 1/4, 5, 1/5, and so on. It's getting smaller and smaller. What about if I plug in a half? If I plug in a positive 1/2, then I get 1 over 1/2, which equals 1 divided by 1/2, which equals 2. So when I have 1/2, I have a 2. When I have 1/3, when x is 1/3, then y is 3. When x is 1/4, then y is 4, and so on. So I'm starting to see that shape now, and maybe I'm even remembering that graph of 1 over x looks like that, and it looks like that in both directions. It's when I have there's a negative negative or a positive positive. So I plug in an x is positive, then my y will be positive. When I plug in a negative, then I'll get y negative. So I'm in the negative negative quadrant and the positive positive quadrant. All right, so that's my 1 over x graph. Now let's talk about the shifts. So we said that my x plus 3, the plus 3 that's with my x, says I'm going to shift horizontally in the opposite direction 3 units. So I'm going to take this graph and shift it left 3 units. Whoops. Let's see if I can get just the graph and not the grid. Let's see if that works. Nope, doesn't work. So I'll just do one at a time. So that's 1, 2, 3, and then I'll do this one too. Hang on. 1, 2, 3. So that's my horizontal shift. And then I also have a vertical shift going up 2. So that let's see here. Let's see. I think I went too far left. I went off my paper and I'm not going to be able to get that graph back. So now I'm going to go up 2. So that's 1, 2. You just kind of pick a point on your graph that is that you can reference. This guy got lost behind, so let's get him up there too. So every point on the graph is shifting left 3 and up 2, but I like to pick a point of reference like the 1, 1 point, for example. Like I can pick this point and know that that point used to be at 1, 1, and now it should be, let's see if it was, I'm going to write that in blue. The point that was at 1, 1 should go to, the x will go left 3, so that's going to be 1 minus 3 is going to give me a negative 2. And the vertical shift, I have plus 2, so y should go increase by 2, and I end up with 3. So that 1, 1 point should now be at negative 2, 3. So that's, let's see, 1, 2, and then 1, 2, 3. So that's that point right there that is now at negative 2, 3. But in the original parent graph, it was at 1, 1. So every point on the graph shifts by minus 3 in the x and plus 2 in the y directions. And you can kind of pick a point of reference to shift. You can also pick the asymptote. It's just something that's easy to reference.